Hello friends, welcome to my channel DataMaking. Please subscribe my channel to get more technology videos. Okay, let us go to today's topic. Let me minimize my recording window. So we were actually in the discussing about the project called Meetup RSVP stream processing, which is Apache, which is based about Apache Spark project using a Scala API. Okay, so last few videos we discussed about the architecture and the environment setup for this project, and we discussed the Kafka producer. Okay, and also we discussed about the Spark structure stream application, which takes the data from Kafka topic and write it into the raw data into the MongoDB. So okay, just I'll give you overview. So this project, basically what we are doing is we are taking the stream data which is publicly available. The meetup.com gives the REST API for streaming the RSVP data. RSVP data is nothing but basically when the people put the events in the meetup.com about their meetup or event. So people go and say RSVP. RSVP is mainly for please reply. So whether they are planning to go to that event, they say yes. The response, they'll say yes. If the response is no, it means they are not going to attend that meeting or the event. Maybe that they may go or may not go. Okay, so all this the stream data is JSON structure. Okay, JSON messages where you see this. This is the one JSON message. I'll show you in the formatted string. So basically, this is the event. Let me show you the event. So for example, this is the event they are hosting. So best of best. More food and adventure. They are going to talk about this event. Okay, so the group is the group name is basically a Singapore adventure group. Okay, adventurous group. Okay, so this is the group details. Okay, and so basically we are interested to look at the response of the particular event, whether they plan people from that group that they plan to go or not. Okay, so this person says Srilin said is planning to go to this event. So yes, so this is a sample RSV message. It's a nested JSON format. Okay, so we are going to read this JSON message using Kafka producer. Okay, I explained you in the last video about this Kafka producer, which actually gets the data from the Meetup stream API and then push it to the topic called the RS. The topic name is basically let me show you a Meetup RSVP topic. Okay, it is going to publish into my local Kafka server. Okay, so then we wrote this this Kafka producer is going to take the data from meetup.com and push it to the Kafka topic. So then we wrote the Spark structure streaming. Okay, using a Scala API. So I am using for the Python producer to write and run it. I am using the PyCharm IDE, and for writing the Scala application for structure streaming, I am using IntelliJ IDE. All these IDs setup, I made a separate videos. Please go through that video, and if you have any queries, please get back to me. So now, last video we discussed about how to actually pass the JSON message and make it as a flat structure and store it in the MongoDB as a raw message. In this video I am going to discuss about the kind of aggregation we are going to do it on the data and store the result into MySQL database. Let me walk through it. Okay, so the first thing is basically this is a SPT based Scala project. Okay, this a project structure will be like this. This is a project directory which will have a source directory and target directory and also dot idea for this project related stuff. This IntelliJ IDE maintains this project, and we'll have project folder. Okay, so this SSRC folder will have the actual source code, means the Java, the Scala classes or Scala object. We are using a Scala object. Okay, So this will have a main method. Okay, so import the necessary Spark SQL packages. Okay, then what we are going to do is we are going to write a main method. Okay, this is the entry point of the Scala object. Okay, so here we just print the message, and then this is the Scala topic information where we are going to consume it. Okay, this is my local Kafka cluster I set up. If you want to know how to set up, please watch my other video to check it. So this is the MySQL details. So I have a MySQL local instance in my system. I am going to make use of that MySQL. Let me open the MySQL workbench. Okay, so I'm using the database called Meetup RSVP. Okay, RSVP. I have a table called uh, a table called Meetup RSVP message aggregate detail table. Okay, this has a sequence number, group name, it's auto generated number just for maintaining the sequence number. I'm using this, but these are the details I'm taking from the RSVP JSON message. So basically, we are interested on a group name, which is what country the group is belongs to, state and city, and what is the latitude, longitude, basically the city is latitude, longitude, which area this group is mainly. And also we are interested that particular RSV message is for yes response or no or maybe, and we are trying to do the count. Okay, so on particular batch interval, so in the Spark success streaming, we set the trigger interval, right? At particular trigger interval, which group is getting a maximum response that we want to see it. Okay, so we can do a lot of aggregation. I'm just starting with this. So further videos will run different do different aggregation on it. And I'm just capturing the batch ID for each batch. I just want to differentiate. Say like how many groups and what are the response we got. Okay, so this is the simple MySQL table where aggregation table I'm going to store the data. Let me drop the existing table. Okay, and create the table. Okay, let me use database and create this table. Currently we don't have any data in this table. We are going to run this uh, the Spark streaming, and we are going to monitor how it is working. So this is a local instance MySQL, and a local host is the local host. By default, the MySQL port number is 3306. The username and password of the MySQL instance. This is my database, meetup underscore rsvp underscore db. This is my MySQL driver which I am using it. So all your dependencies are placed in the build.spd. Okay, so if it is a SPD based project, you will have SPD based project, SPD based Scala project, you will have a build.spd file. So we here we just put all our dependencies here. Okay, now so then we'll have a table name, and this is JDBC URL you need to form to connect to the JDBC, because we are going to write the each batch data frame into the aggregated batch data frame into MySQL database. Okay. This is for MongoDB instance. Okay, I just explained to you in the last video. The first thing is we are going to create a Spark session object. Spark session object is the entry point or the connection. You can say if you are familiar with the database connections. This is a database connection, kind of database connection, which makes your code to run on the cluster, Spark cluster. So it has a master URL which says which cluster manager it is going to connect. A Spark cluster manager. It can be a standalone Spark standalone cluster manager or local mode, or it can be Yarn if you are using Yarn resource manager, the cluster manager. And the name of the project, sorry, name of the application, and then this get a create. So this will create a Spark session object. So a log level, okay, so you can actually set the log level. Okay, so let me I just want to see only I don't want to see the info logs in the last video. Let me this time let me put the log level. I don't set anything, so info message also will get. You'll see a lot of messages coming up. Okay, then this is the way you can actually consume the message from Kafka topic. Okay, so you just the Spark structure streaming API is very easy. You just kind of how you use other data sources, like if it is a JSON data source, if it's the CSV data source, you just say Spark session dot read dot format of the particular data source and provide the options if you are needed, right? Like if you are reading a CSV file, you just say Spark session dot CSV dot format. You don't need to provide format also. So then whether header equal to true or are you going to infer the schema, those kind of property you give, and they say load, right? Similarly, when you want to read it from Kafka, it is very simple. You just say Spark session dot read stream, because we are going to read the stream of data. That's why we are seeing read stream, and the format is Kafka, because we are going to read the Kafka source, and then provide the bootstrap URL, which is server name and port number, bootstrap broker, server broker, or Kafka broker or server. Then provide the subscribe, okay, which is a topic name. Okay, then starting offset, which is basically you want to get the latest message from the Kafka topic, or from beginning a message from the beginning of the beginning. So you can, I want to just get the latest one, and this dot load, which will actually load this data into this data frame for every trigger interval. I set the trigger interval in the back, in the below section of the code. I will explain you. So then we are actually printing the message. Okay, so printing the schema of this data frame. So basically it will have different columns, so like key, offset, and value and timestamp kind of things. So basically we are interested in the value, because in the Spark, in the producer object, when you produce a code, when you actually publish the message in topic, you will actually pass key value pair. Okay, when you construct the message, this key topic name and value will be the entire your JSON message. Okay, that's we are interested on this value field. So we take that. So basically, to parse the data, we need a schema of your JSON. So I just defined this schema. I explained it detailed in the last video. Please go through this. So we are designing. So we are creating a schema for your JSON structure. Similar to this. Okay, so basically we want to parse this, right? So we need to prepare the schema for the JSON structure. Once you prepare a schema, okay, so the schema name is Meetup underscore RSVP underscore message underscore schema. So we just interested on value column, just constitute string, and also timestamp column, constitute timestamp. This is where we are using parsing our JSON. You just say select from JSON the column name is value, and provide the schema, and give that the extracted JSON column value column gives alias as message detail, and the same timestamp column. So in this select class, you provide two. First column you are actually parsing the JSON, second column is same as timestamp. Then the first column you just this will have a column which has entire multiple columns, right? So you want to bring the other all the columns, so you get stars. Then in the now in the new data frame, RSVP Meetup underscore RSVP underscore DF underscore 3 will have a 10 columns. Like with the timestamp column, all your root field of your JSON message, venue, visibility, response, guest, member, event, and group. These columns will be there. Further, we want to flatten the structure, so you just access the individual column with the sub columns or the inner field using the dot operator. So this is how you just flatten your schema. Okay, the nested schema. Now the next step is we want to connect and write a MongoDB. So this is the code to write a MongoDB. You prepare the MongoDB the connection URI and use a for each batch. Basically, this is a stream, right? This is a stream data frame. So you cannot directly write into the different data sources, basically like MongoDB or Cassandra, MySQL, because out of box by default Spark structure streaming is not provided with writing a stream data frame into these data sources. But you can write it into Kafka, another Kafka topic, or SDFS. The stream data frame can be written, but these are not supported yet. So that's why they provide this for each batch, where each batch data frame they will actually give it. Okay, so because you are going to take the so each batch interval you get a new the data frame, right? That batch data frame you can write. So this is how you can write it into MongoDB database. Okay, now it's a normal Spark data frame write operation to different sources. Now the actual logic for aggregation comes. So here what we are doing is actually we are grouping the based on the column like country group name. Okay, so we want to actually find out the each batch our interval that our trigger interval based on the group. Okay, so which group gets more RSVP messages. Okay, so that's what we want to find out, and also we want to find out the count of each response. So basically, yes response, how many is coming for that particular group in the particular batch interval. For no response, and as well as maybe a response. Okay, so that's why I put a group by class. I put all these columns. So basically, I want to group name followed by group country, state, and city, and group lat and long and response. Why I put these columns also in the group by? So I'll tell you. Basically, I want to aggregate this data. Then I want to plot a chart into a map. Okay. So I'm going to have a chart for map as well as the bar chart and other stuff. So that's why I'm actually getting other columns as well. Otherwise, I can just put based on the just group name I can put. But these details also I want it for making a chart, like good looking chart. So it's like writing your SQL query. Select count of the group response count based on these columns. Okay, so you can just say so this is a group by class we provided. Then what is kind of aggregation you are going to do? So this dot agreg is a aggregation method where you can provide the particular aggregation method. So whether count or sum, what is the things you are going to do? This is the actual aggregation method, count. You provide the column, response column. So once you do this, you get a new column, right? The like kind of count of response. You just say dot as they give the new column for it, like response count. So this data frame 5 will be having a column, group name, group country, state, city, and group lat long, and response comma it's another column called response count. So we want to write this into console for debugging purpose. So I'm just saying data frame 5 dot write stream dot trigger. I'm setting the trigger interval 30 seconds, and I'm going to update mode and just giving a to display all the values. I'm just giving truncate false, and I'm going to print in the console. This is for debugging purpose, and this is a place where we are writing into MySQL. So what you need actually driver class for MySQL and user ID password. You prepare this property object with this 3 value, and in the right data frame, it's the right stream. Okay, so what we are going to do is excuse me, sorry. So in the right stream, set the batch interval or the trigger interval, and the output mode as update, because we want to get all this new data and appended data. Okay, updated data and appended data. Okay, so then similar like how we did for Cassandra, sorry, the MongoDB. So we want to, we don't have out of box or default method to write it into MySQL database, the stream data frame. But so they provide the API called or function called for each batch. So it iterates each batch data frame in your stream, and it gives the batch data frame, comma batch ID. So you add the batch ID to the your data frame, and then write the data frame into MySQL. To write data frame to MySQL, data frame dot write dot mode. Okay, so and give the method as append, same mode as append, and dot jdbc, and provide this details like jdbc URL which we formed at the top, and then what is that sorry, table name, which table you want to publish, uh, then the property, MySQL property. Let me print this URL for you to just have a reference. Okay, so this is the one. Okay, so after that we are just waiting for termination. Okay, so this stream, now what is going to happen is going to consume the message from the stream data source, Meetup RSVP stream data source, and push it into the Kafka topic, and from Kafka topic we are going to consume it in the Spark SQL streaming and do this aggregation, save it in the MySQL. Then we'll query the MySQL table and see. Okay, so let me start the Kafka broker. So to start the Kafka server, we need to start the first Zookeeper server on the component, because this is the coordination service we are using for Kafka. Then start the Kafka broker. It is started here at the Zookeeper. By default it starts 281. Now Kafka is starting. Okay, so the Kafka server also started. Now let's go and publish some messages. Okay, so before that I need to create a MongoDB collection which I cleared actually. So the MongoDB collection is basically this is my MongoDB collection name. I'll create that. This is the MongoDB Compass is the GUI interface for MongoDB. You can connect to the MongoDB instance, and you can create all your collection, database, and documents, other stuff. So you provide the instance host name and port number and user ID password if you have user ID password, and the which database you want to connect you provide here, and say connect. So it is going to connect my local MongoDB instance. It's a single node cluster I'm using it. So I already created the database. So I'll just create a connection. Sorry, collection. Collection is nothing but a table in your database. Okay, now we are going to publish the message. We take the stream data from meetup.com. Okay, so we are going to publish it. It is started publishing the data. Okay, let's have a streaming application to run. So basically I am running on local mode. The multiple components I am running in my local mode. So that's why it's a little slow. If you are running on cluster Hadoop with a Spark cluster, it will run basically very fast. Okay. So it has started consuming the messages. Okay, because I removed the log level as error, so it is going to show all your info logs. It will be huge number logs. Okay, it's very difficult to track because it's keep on running, right? So let me maximize it. Okay, so let's check whether something is completed. Not yet. First batch result yet to come. Okay, so it has come. So let's run this. Not yet. It's still writing. It is written on the console, but still it will write into MySQL. It's 88 plus 88 out of. So basically, this is going to write a data, the aggregated data into MySQL. So let me check the whether it written into MongoDB. Okay, let's refresh this. Okay, go to the MongoDB. It written 15 documents in the raw data into the the RSVP message into the MongoDB. Okay, now we should see this into MySQL, the aggregated data into MySQL. I hope. Okay, still one more task, few more tasks. It's 112 task is completed. Okay, yeah, first data has come. So there is a group called Mumbai Weekend Events India, and the city is Mumbai. This is a lat long, and we got that particular batch. Actually, we got only one message from this group. Okay, let's run for couple of iteration. Then you will see actually a lot of messages getting published into topics. Okay, and it's getting aggregated here. Okay. Okay, so now you see there are many RSVP messages come. It got aggregated, and we saw there is see in USA. Okay, there is a group called over 40 single hikers and adventures. They got in the particular batch interval. We got 2 RSVP message saying yes, and some people are saying no for few meetup or events. So that's what. So this first batch, it is 0th batch. We got only one RSVP message for this group, and from the second batch we got a lot of RSVP message, and it got aggregated. Okay, this is how we want to get it. In the next step is we'll actually build a chart using a chart and dashboard using a Python visualization package called Python Dash, and we'll actually plot this chart in bar chart, bar graph, and we'll try to put this group into the Google map or any map open source provider to just plot this latitude and longitude. Okay, I hope this video is helpful for you. Please subscribe to my channel to get more technology videos. Okay, so I actually have a different playlist for machine learning, Python, and other Spark concept. So I build a separate playlist for PySpark. Okay, so and there are 24 videos till now I prepared. So I prepared a new playlist for Apache Spark 101 tutorial, which has Scala based examples. Okay, see you in the next video, friends. Thank you so much.